Okay, we're on. Everyone's working on, Brian, take a seat, like we talked about. These two problems.
Sorry.
What do you need notes? Page 26, one multiple choice, finding the roots, one by hand, finding the roots, but it's already factored for you.
Yeah, Tuesday's going to be definitely a big lesson, so just make sure, you're welcome to go, but make sure that you are going to have now for next week, everybody on the break. And you can either watch the video
You said page 26, so you can
or come to all of us again.
That's our last round.
You did.
No. Why y'all snitching on me?
Deal with it.
That's our last round.
Everyone else, what should you be doing? Everyone else. Your do first. Everyone else, all I want you to be doing is your do first. Israel, do your do first.
Is you recording?
Okay, you should be finished here in about 30 seconds. I'm going to take attendance.
I think I know a couple people that wrote that because they did cubes and they just like did that. Does that make sense? It's a little thing. That's like a small tweak. Okie dokie. Let's take a look. So, happy Thursday. It's kind of a Friday. Woo! You're nearly there.
Is it wrap?
I know, I forgot. I didn't even think about that because I still have work tomorrow, so I still feel like it's not Friday yet. So sorry, no raffle. It's gonna be for like Sacred for Fridays, even though it's the end of the week. But I actually might, like other times that it's a Thursday and we don't have school Friday, I might do it. But I just didn't even think that would happen. I'm actually out of raffle tickets. If I ordered them on Amazon, I just got a new giant wheel of them, so we'll be good for the year. I sell everything on Amazon. You can do everything from home. Amazon Prime is probably the best decision I've ever made. Because I ordered a lot. Actually, it could be the worst decision because now it encourages me to buy more. I'm not as bad as my sister-in-law. I think every time I go to their house, I see an Amazon box outside. I'm not that crazy. But if I need something, I don't have a lot of time other than on the weekend to go shopping for random things like that. So I just do it online. No, I've never done that, but I think he told me that. Anyways. Okay, so let's get started. We got a couple more periods, so hang with me. Today, or yesterday we had our quiz, so you just got that back. Great job on those. If you weren't super thrilled with your score, I think most people are probably pretty happy with theirs because people did really well. If you weren't, then make sure you get some of those things cleared up with me, or maybe it was just little mistakes, so that you can remember there's one more quiz and then the unit exam, and those will FA this score. But we are going to be next week going on to some new things, and so we want to make sure we feel good about this stuff so that we can move on and like focus our energy on practicing the new stuff, okay? So today we're going to be talking more about related things to synthetic division. So we're going to be talking about factors and roots and all the things like we did on Tuesday, and how we can use synthetic to help us. So, since we're in the land of roots and zeros, let's talk about the roots of these two equations. This is an equation that's basically in what we would call standard form, like the form that's like cubed and squared and all that stuff all the way down the line. This is something that's already factored. Which one of these is easier, like from the get-go? Raise your hand and tell me which one's easier from the get-go to identify your roots or zeros, like factored form or standard form. Which one is like more helpful, Giselle? Factored form. Once it's factored, we say, maybe not these ones, but like this one, we say x equals what? 2, right? So if we can get this to factored form, then we can find our roots. And if it's a quadratic, you can do that with your box. I'm not going to do the entire box right now. If you struggled, it might be because this is one where you have a not equal to 1, which means you need to multiply and get negative 24. You're looking for factors of negative 24 that we could add and get 5. So that's a hint on that one. But fast forward, someone that already did this box, raise your hand if you have the factored form for me, so we can write the factored form and find our factors. Diego?
X plus 4,
Mm-hmm.
and then 2x minus 3.
Cool. So that's our factored form. So even someone that maybe didn't get that, now we should be able to find our actual factors. Can I get someone to tell me now which F, G, H, or J would be our final answer? Lyria, go for it.
Okay.
J is correct. If for that second one, you need to actually set it equal to 0 and like solve, you can, but you're going to see more of these today and get kind of good at just seeing that 2x minus 3, your root then would be 3/2. Alright, down at this one, you got 1, 2, 3, 4, I believe, that we should be able to list out. Anyone, raise your hand if you can give me all 4 of them. All 4 of them, even if you didn't do it already, like you should be able to look right now, and you might be able to do it kind of quickly in your head. So take a look. This is your chance to get a stamp. Everyone wants the stamps? Eli, what do you think?
X equals 0, x equals 2, x equals 7/4,
Close, negative 7/4.
x 7/4, and x equals 11.
And so for these ones, it's funny, everyone today so far has given me 0 and 2 first. And then they like went to these ones after. They're like, ooh, scary. But if you have 4x plus 7, and you're trying to find the root where it's equal to 0, we could subtract 7 and then divide by 4. Sorry, subtract 7, so minus 7/4. But you'll notice in all of these, 7/4, 11/3, right? And then you just have to think 3/2. You just have to think about your sign. So we'll start to get better at that. So quick check. Anyone, raise your hand. Based off of that, really quickly, without actually setting it equal to 0, can someone tell me the root if this was our factor? Sandy? 1/3. Cool. Okay. Very nice. Roots. We love roots. Reminder, your problem set is due on, who was it? Jan? Did you say it? No. It's Sandy. I know, but earlier. Who did I call on earlier? Eli. Okay, I knew someone over here. I just know general direction. I'm like, there's a stamp over there that I need to go. I got too many things going on in my head. I can't keep track of it. Yeah. Sometimes I feel like Dory. Okay. So it's due on oh my gosh. It's due on Tuesday. Zeros of polynomial functions. Let's talk about how we can find our zeros or how we can find our roots using something handy that we call the rational root theorem or the rational zero theorem. Before we do that, we're going to kind of work backwards, okay? So our do first, I gave you an equation. One was in standard form, one was factored. You gave me the roots, right? What you're going to do right now is I'm giving you the roots. You together are going to build the polynomial by writing it in factored form, and then you're going to think about if you can multiply it out to get it back into standard form. If you take a close look, I didn't realize, but the one on yours I think is slightly different than what I have on the PowerPoint. You have x equals 2, x equals -2, right? X equals -2/3. If y'all could, if you don't mind, since I already have all this animated, if you can just cross off x equals 0, because I just want to keep it the same as what I already have up here, because I tried in the last class to do it with your version, and then just all my answers kept being wrong, and we had to, it was kind of a fiasco. So, let's cross that one off, and I want you to find a polynomial in factored form, and then see if you can find it in standard form that would have these 3 roots, okay? Talk to each other. We're going to come back and share out, so be ready to share out 4 stamps. Talk to each other, see what you come up with. Go.
Okay, let's do it.
Good, and then now how would you put this in standard form? Yeah, how would we make something like that look like this? What can I do to go all the way backwards to this? Yeah, like you're going to have to multiply these together. Kind of like, see, wasn't the 2x plus 3 and the x plus 4 here? And so you're basically going to do the box where these are the outsides, and you're going to find the inside. And then what you get, you're going to have to go and multiply together. So start with these two, start with boxes. Okay, now we're going to have to, so again, ignore the 0 one, so erase that part. But this looks good. So do a box with these to start multiplying them out. And then this one would be 3x plus 2 to give you the -2/3. 2/3. Yeah, no, you subtract the 2 and then divide by 3.
And then it'll flip all of them.
Do a box. So start with your box with these 2, and then we're going to multiply times the other one. So this is standard form. So it's like this factor. And we want to also, sorry, this factor form. We want to get standard form as well, which means taking your factors and like re-getting the stuff inside the box. So start with a box with just these 2. What do we got? Perfect. Okay, so this is factor form. Now it's multiplied into standard form. Start by doing your box with these 2. See, let's see? Lovely. So that's factored form. So now we want to put that factored form that we all got on our papers in standard form. So multiply it all back out. So x plus 2 and x minus 2. Start with those in a box for me. And then we'll deal with the other one after. Come on. Okay, can you try to multiply these out into standard form? So start with your box with everything x minus 2. Lovely, we got someone already multiplied it all out. We want to be after. We would have to have X.
It's on the right. There's like a five.
Right?
Only three. Only couple you guys are just need to be able to jump.
Right?
You guys be a guard. Yeah, the harmony's right here.
Lovely. Start with the box.
These are already. So, between.
You multiply them all?
Yeah.
Keep going.
I stopped.
It doesn't, yeah, that
Hey, how do you get there?
This is going to be the obvious for most people to go with, and we're going to go with, but there are I don't. Falling over is like crossing those boxes, right? And technically, like I can put it as there, right? And it's
You don't have red dress.
so there's like one who goes there, but most people are going to do this. Okay. Eyes up here, let's move quickly through the rest of this problem. Join me back up here. I'm gonna try that again. Join me back up here. Wonderful. Okay. Let's start first with the factored form, because I think most of us jumped to that first because we were given our our roots or our zeros. So factored form, D and Theo, what did you get?
f of x equals x plus 2 times x minus 2 times 3x plus 2.
Cool. Technically, wonderful. Technically, this was not the only one you could have done. I think this is the one that most of us had as like our go-to. But I was talking with Giselle and Messiah, like these three places on our graph, 2, -2, and like -2/3, wherever that is, there's a lot of graphs that could pass through those places, right? I could change this to squared, and it would still have that root, but now it would just do what at 2? Instead of crossing, it would do what? Down. So like, there's actually a lot, but we're gonna go with this one because this is the one that probably most of us wrote down, that have roots at those three places. And now we're gonna multiply it into standard form. So to multiply all this out, I got a lot of y'all did your box with x minus 2 and x plus 2, so can someone raise their hand, tell me what they got for just this first part right now? Sandy?
That's 4 minus 4.
Cool. The minus 2x and the plus 2x cancel, and we end up with that, which we still have times 3x plus 2. So now you just have to do another box to multiply this.
Oh god.
And let's take a look if you haven't already. 3x times x squared will be 3x cubed, good. X squared and 2x will be 2x squared. 3x and -4 will be minus 12x. 2 and a minus 4 will be a minus 8, which brings my f of x to be 3x squared plus 2x squared, 3x cubed plus 2x squared minus 12x plus 8. Kennedy.
So is there like a problem with multiplying it without using the box?
Yes, what did you do? Or not necessarily. What did you do? Did you get this?
I didn't finish it.
Okay.
But couldn't you just move the distribution, but like one at a time?
Yeah, you gotta just be careful that when you're distributing, you're getting every term to every term. But there's ways, like when I was growing up, for example, we actually didn't use the box. We just, you just multiplied, the first, they did kind of this thing called FOIL, you multiplied the first ones, then the outer ones, then the inner ones, then the last ones, and you made sure you got all of them. And as long as you get all of them multiplied times each other, you'll get the same answer. So I can come kind of check it if you'd like to try that, okay? Cool. Alright, so we've got our cubic. Time out.
Why is it positive?
Oh.
Oh. Why is it positive what?
Positive 8.
Oh. Should it be minus?
Next one.
Get out of your box. Thanks. Is that right? Okay, thanks. Sometimes I got mistakes on the PowerPoint. It's okay. Man, a rough day for the PowerPoint. PowerPoint's struggling. I'm not struggling. PowerPoint's struggling now. Okay. -8. Happy? Okay. So, you probably were wondering, because I know you're all always wondering things and thinking critically about things. You might be wondering, like, it's nice and all to factor things. However, is there a relationship between this standard form and these random numbers right here? Did this 2 and this -2 and this -2/3 somehow, could we like see those numbers from our original equation? Okay, so the rational root theorem, okay, Evan, perfect. The rational root theorem is going to be something that connects our standard form directly to our roots and kind of like helps us out to see where do these roots come from, okay? So let's turn to the rational root theorem, and I'm going to use this example right here that Eli has so kindly noticed is, I believe, a -8, but it's hard to cover up a plus sign, so bear with me. So let's read about the rational root theorem, and we're going to connect it back to this example right here. Follow with me. The rational zero theorem, or the rational root theorem, describes how the, box this, leading coefficient, box it, leading coefficient, which the leading coefficient from our example would be 3, right? It's the coefficient, that same thing that you looked for positive or negative when we did our end behavior, right? Okay. And we're going to describe the leading coefficient and the constant term of a polynomial. The constant term is this term over here, our -8, which is the one that like doesn't have an x with it, right? It's like x to the 0 power. So that's our constant term of a polynomial function with integer coefficients. Can be used, these two numbers can be used to determine a list of all the possible rational zeros. Now, this theorem is not going to give us exactly 2, -2, and -2/3. Or that's how we would solve it. We wouldn't factor it. We would solve it that way. It's just going to give us a list of possibilities and narrow down from like all the numbers in the world to a smaller list where I could say, because I know the rule, looking at this, y'all don't know it yet, but I know the rule. I could have looked at this and said, I know that x equals 5, it's definitely not going to be one of my answers. It's not going to be a root because of the rational root theorem. Okay? Y'all going into it like we're like any number could work, right? Okay? So let's take a look at what this leading coefficient and this constant term are telling us. Okay. So if we have a polynomial function, here it is, and it could have any numbers, so they're using like a's and x's and all this stuff, but let's use an example with numbers. Okay? If it has a degree n greater than 1, which ours has a degree of 3, and integer coefficients, we've got 3, 2, -12, all those, and a0 is not 0, this last one is not 0, right? Then, every rational zero, these guys, has the form p over q, where, let's skip to this one, p is a factor of the constant term. P is a factor of, in our case, 8. And Q is a factor of the leading coefficient, which in our case is our 3. Okay? So the only possibilities for these roots are for our numbers to come from factors of, in this example, 8 over factors of 3. Let's check. 2/3. Is 2 the top, a factor of 8? Is 3 a factor of 3? Yes, so let's check -2. That's technically like -2 over 1, right? Is -2 on the top a factor of 8? Is 1 a factor of 3? 1 times 3 is 3, so 1's a factor of everything, right? Okay. And then this one, 2 over 1. 2 is a factor of 8, and 1's a factor of 3, right? So that's why those 3 were part of our possibilities. Like I said, 5, I said I knew was not going to work, because is 5 going to be a factor of 8 over a factor of 1? No. So you can at least eliminate a bunch of the guys and like the numbers in the world that are not going to be even possibilities of being our factors. I mean our roots. Okay? Cool? So today we're going to be like listing the possibilities, and then we're going to be testing them because we learned on Tuesday how to test factors, right? By doing synthetic. So we're going to be able to test them with synthetic to see if they actually work or not. Okay? Well, let's jump on in. Model problem 1. Join me. To the top of the page. Okay. X to the 4th plus 4x cubed minus 12x minus 9. Got it? Okay. We want, I have my poster up here. I'm going to write, just to make things simple, even though this isn't like perfectly accurate, factors of the last, because that's like our constant term, over factors of the first, our leading coefficient. But I have like a little story here. If your polynomial is ordered by the exponents from greatest to least, right? You got to make sure it's in order before you say first and last. Okay, well let's take a look. Factors of the last. So to find our possibilities, we're going to take factors of, what's our last? Cool. Over factors of the first, which by that I mean the leading coefficient, which if there's nothing there is what? 1. Martin, you writing this down? Factors of -9 over factors of 1. Now let's find those possibilities. Raise your hand if you can tell me the factors of -9. What times what will give us -9? It's a good chance for some stamps. Bring it back to the factors. Melanie? 3 will be 1. And I'm going to say for any of these numbers, we can actually say the positive or the negative, because you could do -3 times 3 or 3 times -3, all those possibilities, okay? There's always also going to be 1 and the number itself, right? So we should also always have, like for this one, plus or minus 1 and plus or minus 9, because 1 times 9 is 3. Missing any? No, that's all of them, right? Okay. On the bottom, factors of 1, we just have plus or minus 1. Which makes our life easier, because if there were more on the bottom, we would have to take the numbers on top and divide them by each of the numbers on the bottom. We only have 1 to divide by. And dividing by 1 is nice and easy, right? Because what's 1 divided by 1? 1. So we're just going to get all the numbers on the top, right? So plus or minus 1 came from 1 divided by 1. Plus or minus 3, because of 3 divided by 1. Plus or minus 9 from 9 divided by 1. Cool? So that means we've narrowed the roots of this function down from any number in the world to 1, 2, 3, 4, 5, 6 numbers, right? Because 1 and -1 are 2 separate numbers. So 6 possible numbers. You could go do synthetic on all 6 of these numbers. It would take 6 synthetics, but it's possible. And using synthetic, you could tell whether they actually are a 0 or not. What should happen in your synthetic if this is a root or a 0? Talk to your neighbors really quickly. What should happen to your synthetic? What should you get with your synthetic if it's a root or a 0? What about the remainder? The remainder should be what? What should the remainder be? 0. The remainder is 0. Then it would be factor that makes the number 0. Alright. I should see lots of hands. Then you chatted with your neighbors. This is your chance to steal your neighbor's answer and share it out for a participation stamp if you weren't sure yourself. What should I get with my synthetic if your number is actually a factor, a root of our polynomial? Kennedy?
The remainder will equal 0.
The remainder is 0. We did that on Tuesday. If the remainder is 0, we said it's a factor, which means this number would be our root or a 0. Okay? Cool. So we're going to be testing that in a second. I'm not going to make you test like all 6 of these, but you'll be testing some to check and see like actually is it or not. Okay? Cool. Let's for now just stick with listing them. Then we'll go test things out with synthetic. Take a look at this next one. I want you to start off by writing factors of blah and factors of blah. I want you to go ahead with your neighbors, get started on this problem, then we'll check in about a minute and finish it off together. Start listing the possible roots of this polynomial. So the constant term, because we don't, I'm just trying to like simplify for the poster. I could say factors of the constant term, factors of the leading coefficient, but people later are like, what is that? So this is just my simple version. The constant term is always this guy that if it's in order is our last. Because that's why I said when the polynomials are from greatest to least, the last is going to be the constant, and the first is going to be that leading coefficient. Well, this is just like so that I can fit it on my poster and use like simple. It's so. Well, and then plus or minus for all those, right? So factors of what's your last? Factors of your last go on top. So factors of 8. Sorry, factors of 8 over. And then factors of your first term is 3. Cool? And then you're going to list the factors on the bottom. Really quick, write your factors of 3 and then you can go. Lovely. Can I use yours as an example? Alright, I'll bring this right back to you. Oh jeez, blockade over here. Can't get through. It's alright. There's a lot of people in the class. Do you like that seat? Is better? As long as y'all aren't chit-chat. Okay, people. Apologies. Okay, I'm going to use this example. Voices off, eyes back here. Okay, we're going to go with factors of 8 on the top, factors of 3 on the bottom. So if you notice right here, we've got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1, plus or minus 3. Got it? Okay, now this is not the end of your list. I know it's kind of annoying, but you actually have to list out the numbers that are this divided by this and all the possibilities. So I'll show you what Brandon did right here that I'm covering up, and y'all can take a look. First off, he got 1, 2, 4, and 8 because that's what we get from doing any of these numbers divided by 1, right? So let's list those out. Positive 1 and 2, sorry, can't talk. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Write those out. Then we also have to take all of those numbers and divide them by what? 3. So he also got 2/3, 4/3, 8/3, and there's just one missing. Which one?
1/3.
Plus or minus 1/3 as well, right? Do we see where all those came from? Yeah. This one's different because the other time we only had 1 on the bottom. This is what it looks like if you have 2 factors on the bottom. Or sorry, 4. So positive and negative. Okay, so in total this time, we've got 1, 2, 3, 4, 5, 6, 7, 8, but then positive or negative, so 16, right? Numbers sitting there. Okay? That means you've got 16 possibilities. So if you were to go check all of them, you would do synthetic division 16 times to check each number and see if your remainder was 0. So again, I'm not gonna make you do that, but you need to know that that is the process. And it seems like a lot, because it is a lot, but before this, when we were if we're trying to factor this and come up with our roots, we don't even have a starting point. It's like, pick any number in the world for synthetic. There's way more than 16 that we could have picked from. Infinitely many, right? Think like half of them are fractions too. You'd be picking random fractions forever. Okay? So the rational root theorem is really helpful for us to narrow down our choices and then try synthetic with some of these. Alright? I saw a lot of your faces when I said you'd have to do synthetic 16 times. Where'd my presentation go? There it is. Let me fast forward. Okay, so What's happening?
It's time.
Stop.
Let's try again. Wait, scoot it away. Okay, good, cool. So, originally, when I was looking at this lesson, I think it like, they wanted you to, the direction said, take a look, the direction said, for example, this one right here, which is not in your notes, it said, for this function, determine the possible roots, then determine which, if any, are zeros, which means like, do synthetic on all of these, plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21, plus or minus 7/3. So I went ahead and I did synthetic, so let's take a look. I'm not going to have you do it, but I want you to look at my synthetic. I did it for you. You're welcome. I tested 1, I got -8, so what's true about 1? Sorry, not a root, that's like not accurate. Not a root. -1, I got 0, so it's not a root either. And 7, not a root. -7, not a root. I actually went through all these and none of them even worked. So I did all that work and none of them even worked. Because it's possible for a polynomial to not even cross the x-axis, right? It's possible. It could be up here and it could never even cross. There could be no roots. So when you're doing this, it's helpful again to have the rational root theorem, but also you still got a lot of synthetic that you would have to try. So here's the compromise I came up with for you guys on your problem set and for the rest of the practice problems. What I want you to do, Lazaro, you still with me? I know, we're rounding out till the end of the week. Stick with me. If you look at the top of the next page, let's read the directions and see what we have to do, because I'm not going to make you do all of the synthetic divisions. Take a look. It says, and Brandon, I'm bringing back your paper in just a second. It says, using the following polynomials, list all the possible rational zeros. That's what we just practiced, right? And then, do what? Pick 2. Instead of doing all 16 or all 10 like I did, you get to pick 2. And you can kind of make it a game. Like, try to pick and see if you can find one that's a root. Like, you're like, ooh, 5 is my lucky number. I'm going to pick 5 for my list. And I want you to do synthetic. If you get 0 as your remainder, you get to say it's a root. If you don't, you say it's not a root. So I just want you to check 2 just to practice that. And actually, from our whole class, because we're going to be picking different ones, we'll actually be able to test out a lot of them and see which ones are roots and which ones aren't. Okay? After you finish this problem, you're just going to continue working through the practice. There is even practice down at the bottom that says mixed review. That goes back to practicing some old things. I'm giving you over 10 minutes of practice time right now, which means you need to be super focused. I know I talk a lot up here, so I'm giving you the time now to work without just having to listen to me, which means I need focused practice, okay? I'll be walking around to answer questions. Try it out, see what you come up with. Go! Start this first. Once you do one problem, then you can go. Thanks, sir. Cool? Jump on in. Factors of blah, and then test 2 of them. Good. I don't think you're missing just a zero, because you would do 5 times what? Good, so 6 should be in there too, right? And then 3 times 10, and then I think there should be 2 times something. So you're just have to do more. 2 times, yeah. Okay, now pick 2 and do 2 synthetics for me to see if they're factors or not. Do anyone want a stamp? I'm thinking about Brandon one because I used it for lovely. Now, if you divide all these by 1, it's going to be all these, right? This one's not that bad where you don't have to like mix them up. Pick 2 from the list. Cool. And do synthetics. 1 times 30, 2 times something, 15, 3 times, good, 4, does 4 work? No, so now skip that, 5 times, and then you're back to 60 and start repeating, so you're good. So I go in order until I start repeating, so I make sure I don't miss one. So 5, we did synthetic, did I get you 0? So 5 is not a factor. I mean,
I'm saying that not a group.
By factor, that means x minus 5 is not a factor. X equals 5 is not a group or a zero. Lovely. He picks 10, and then the numbers got big. You just pick 2, so if you want to switch. Pick your 2. How are we doing over here?
What do you want then?
So now you pick 2 of them. Because these are all your possibilities.
Watch them out.
You want to know which one, like literally where is it going to cross? It's not going to cross all those places. So now we got to pick you can test all your one. How many you don't have to for those way too many.
You know what?
So
we just
I'm helping you. I'm number 5. So set up your suspect on 5. Good. And now we need to see if you get a remainder of 0. You would have to do that for all 3. That's not
For real.
yeah, like I did them all. Otherwise, you don't have to. But the actual process to factor something that looks like this and check where all the roots are, because I don't have like box method or something to the 4th power, I use the rational root here, but then I have to divide by all these to see if I can do that.
Whatever number. A big number for -2.
Okay. Yeah, keep going. Just making sure they're focused.
Hey, hold on. Topic.
A big number for -2.
Okay. Go ahead.
Dang. It's just us.
If your like term this was 3xy, this is 3xy squared, those are not like terms, because like terms have to have the same base and the same power. But as long as it has the same base and the same power, you can have a But if you break it, the problem is this table is real. You already done your 2 and going on your multiple choice? Keep going. Lovely. So, is 3 a root? Is it going to cross? No. So at 3, it's not going to cross the x-axis. So that is not. Pick one more to test.
-2 is not a factor.
You can guess, happen to guess one that works. Here's 5 that will end up working, and the rest
I think it's fine.
See how lucky you'll be. So this, you are doing the same thing, but then you're actually testing it. So what you missed was I was talking about how when I list these out, they're my possibilities. It doesn't mean you. Like they're definitely not all my roots, so I don't cross the axis that many times, right? So I can do synthetic with all of them, which takes a while, to see which ones give me 0 at the end and are roots and which ones are not. So I'm not going to make you do it for all of them. I'm going to make you do and then just keep going on to those multiple choice. Watch your conversations, make sure they're about what you're working on. If not, check yourself to make sure you're making the most of your time. So if you have something cubic, quartic to the 4th power, if I'm trying to factor this and find the roots, all you have to do is a 5 here. You don't have a box method. Like you don't have a box method. You have the synthetic with.
You can't do that.
But if I were to jump in and do it, I in the past have given you something in this case, I'm not giving you anything contested. You would be picking out all the numbers to do.
No, I broke it.
You would have to follow your screen.
In football, man.
On tests, you'll have like either multiple choice, which means you're testing the 4 that are there. And then 4 or 5 you then to see if you get 0. But then right on this one, you gotta do this whole page and need super focus. Or with your free response, on it again, If I'm trying to by roots or zeros, picture it, that's where your graph is crossing the x-axis, right? It's definitely not crossing at all. It's only crossing at most if we use our rule. It should cross right the maximum number of zeros. So we definitely need to narrow this down. So these are our possibilities, but they're not all actually. So we can do is now use synthetic, because we use Monday and Tuesday to check whether something is a factor, and so therefore whether. So I'm just telling you, instead of having to use synthetic.
No, I had to
It says 1.756
Multiplying is a 1. If it's like there's not a number, say 21 was not here, then that means that like adding everything's like multiplying. Okay, so Brian, you got your listeners, now you're testing 5? Cool, so write out your coefficients. So in front of the x to the fourth is a 1, good. Then a -1, there's not much It looks like you did factors of, okay, good, yep. So then 2/3 would be 2 over 3, so that's there. -2 would be 2 over 1, 6 is not, yeah.
Yeah, right.
Yep, good. Yep, keep going. So now it's just, we're going to leave behind the stuff from today, and it's just like old review to make sure we got all of it. How would you like? Good. So now on this one, list out your possibilities. For this one, and which one is the possibility? Cool. Good. So this list was able to help us eliminate one of them. Cool. Okay, on to mixed review. For these, let me see. This is like slightly different. So you can go back to just like normal synthetic, because this is mixed review of if we know x plus 2 is a factor, when you do your box with -2, you should get 0 at the end of the factor. That means your answer to your synthetic, right? Remember, this is actually a polynomial. That's 1 degree less. So if this is cubic, when you do synthetic, you're going to have what? X is 1 less squared. And then you can do your box with anything x squared, right? To find your other factors. Synthetic with that, and then box factor to finish factoring.
Did you list them?
Yeah. No problem, no.
Synthetic division by this.
Alright, I'm gonna bring it back up here to have you check your answers and whatever you got through. So bring it back so that we can get out on time. Don't back up, I want you to actually check your answers. So hold us, check, make sure you got them. Use this time as valuable practice time. Okay, for the first one, I went ahead and did all of them so that you can check. Based off of what you picked, if you happen to pick 1, -1, -5, or 6, you should have gotten 0 for those, because those are roots. If you picked any of the other numbers, like if you picked 3, for example, you should have gotten not a factor, because all of them gave you something else. These are the only ones that should have given you a yes. Okay? For the next one, B was the only one not in the list. For this one, H, if you go back to doing normal, synthetic, and then factoring. And then for this last one, I used the strategy of just plugging in and seeing which one worked, and 16 worked. You got 5 on both sides. Okay? Before you go back.
What I'm saying, right?
Are you ready?
Yeah, you know what I'm saying, right?
Thank you for watching, guys. Thank you, thank you.
Motivation speak. Motivation speak. Motivation speak. Motivation speak.
You guys, Derek, up your gym, guys. All right, let's stop the video in 3, 2, 1. Thank you, subscribe. Thank you.